Okay.
Hello.
Greetings.
I like the Stargate background.
Thank you.
I saw you in the corner earlier, like on the left side past the green screen.
Oh, okay, yeah. Let's see. My wife says, don't show what a mess the house is. Hunkering down here, okay. All right, bear with me a minute. I had an example here and I can't find it now. Now that I've unmuted myself, let me say again, welcome everybody. Any comments about whether you like Zoom better or the YouTube streaming?
Zoom is way better. We can ask questions right away this way.
Okay, yep, that's my, I can get some feedback too, even when half of you are asleep. So my preference is Zoom, so I think we're going to do Zoom. If somebody, actually, I got an email from somebody that said they actually prefer the other one. So if you prefer the other one, I hear a couple of Zoom comments here, Zoom and Zoom. If you prefer the other one, it looks like, based on the comments I'm seeing, it may be a hard sell, but let me know, and if there's pedagogical reasons, we'll go back and forth if we need to.
Did you get my email yesterday? No?
No, Ben, the answer is I get approximately 40 emails an hour. And I have been trying to respond to all of them. And is it something you can say in front of the class? And I can.
Yes. The link that you sent the other day for the recording of this,
Okay.
I put it in, and
It didn't
with
work.
the two
And-
equal signs, and I was given an error page.
Okay, last night, I don't know, 10 o'clock or so, I figured out how to figure out where it saves the recording. I thought I sent out an email to everybody saying it was on the M drive now. Thumbs up, thumbs down. Did anybody else get that email? Okay, sis. Okay, see a couple of thumbs up. Yeah, check your email. It was around 10 o'clock last night. Let me see when I sent it out. Sent items.
I see it.
Okay. Yep, I sent it out. And that is the link. It's now on Drive M, and that's where I'll continue to put stuff.
Oh yeah, that's the background. That's what I'm going with.
Okay. So some notes from system administrator. And this is more, not so much because he cares, but because you're going to care. A lot of you, when you come in with the VMware Horizon client to do stuff, you're VPNing in first. It is not necessary to VPN in first to use the Horizon client, and it slows you down considerably. Because this is my understanding, and I think this is correct. The VPN servers don't actually live on the campus. They're rented from somebody, and it could be in another state someplace. Probably is in another state. So when you VPN into campus, all your communications go to the campus, then from the campus to Nevada or some server farm someplace, then back to the campus, then out to you, as opposed to from you directly to Nevada, which then goes to the campus as it needs to. So don't VPN in if you're doing Horizon client, it will be a lot faster. The other questions that one of the common questions I've gotten from last time, and we're gonna work on that a little bit more, what we were doing last time, and is where did that minus 65 or whatever it has come from? How did you know it was 65 cycles? And I'm gonna try doing whiteboard. Why do I do whiteboard? Share socket, share screen, no. Event sharing options, no. All right, here's what we're going to do. We're not going to do whiteboard. I'm just going to do a share screen. So let's do this. Let me do this thing. I've actually bought a third monitor, which will make life a lot easier, but I haven't put it in yet. So got that yesterday.
I imagine he just has like a supervillain style setup in a lair somewhere.
I don't want to comment on that. All right. Can you see a notepad window now?
Yeah.
Yes.
Okay. So the question is why minus 65 in the timer for the timer routine? All right. And the answer to that is based on reaction time of your eye. Strobing needs to happen at minimum 24 times per second. And the reason I say that, it might even be 60, 24 is kind of smooth. I think in the cinema, you see either 24 or 30 frames per second now. Television is 30 frames per second. A good monitor will refresh 60 times per second. And really good monitors refresh at 90 times per second. If you're playing a super duper scrolling or super duper kind of shoot 'em up game, 90 frames per second is perceived as complete motion and with no jumps. Movies originally, home movies, I think, were 16 frames per second. So we got to decide on some sort of a frame rate. I kind of arbitrarily said, let's do 60 frames a second. So if we flash each segment 60 times per second, then your eye should perceive it as constantly on. If we took the extreme other side, suppose we flashed each one once per second, you would definitely see that there was this one's on, then this one's on, then this one flashes, and so on. So arbitrarily, we kind of said, let's say we're kind of a good monitor. We're going to strobe at 60 times per second. So 60 hertz times 4 gives us 240 hertz. So we've got to do something once every 240th of a second. And how do we get that? Do we get something to happen every 240th of a second? All right, so the answer is, let's look at, well, what is a period? T is equal to 1 over 240, which is equal to 4.166 milliseconds. Now, before vacation and in recent days, we've looked at the timer. In the divide by 1 mode, 1 tick of the timer is, so in divide by 1 mode, 1 timer tick is equal to 62.5 nanoseconds, otherwise known as 1 over 16 megahertz. So how many clock cycles, that is, how many of those 16 megahertz clock cycles do I need to get 4.166 milliseconds? And I'm kind of going through the derivation because at some point you're going to have to do some derivations for times. So how many of the 62.5 nanosecond ticks are in 4.166 milliseconds? All right, and the answer is, well, 4.166 milliseconds divided by 62.5 nanoseconds is, I feel like we might be in the end times here with all these 666s, but hopefully not. All right, so it's 66,667 ticks if we are doing divide by 1. Now, could I use a 16-bit timer to do that? What's the maximum number of ticks I can use on a 16-bit timer? Well, maximum number of ticks is 65,535. So I could probably say, well, instead of running this at 240 hertz, I'll run it at 250 hertz or something like that, and use the divide by 1. But then you've also got to ask the question of, do you want to save the 16-bit timers for something else? And do we really need that great of precision? If we're off by a little bit, is it going to make a lot of difference? If this was like pulsing a thruster on a satellite, I'd be a lot more concerned about being exact, but where it's flashing and we're already at least a factor of 2 in the safety zone, I mean, 30 frames would probably be fine. We're doing 60 frames a second. Probably if we're off by a little bit, that's not a big deal. So,
I ran mine at 24 and it was fine. So
okay, so you ran it at 24, and that's good to know. Be interesting if you want to play with it to see what's the minimum frequency you can run it at. Minimum frequency, yeah.
I did some experimenting with it, and it seems like the peripheral vision's more sensitive than the I don't know what it's called, but the primary part of your vision.
Like
so that might be fun to play with.
So if you're looking at it out of the corner of your eye, you can see the flicker?
A little bit, yeah.
Really? Okay. I guess that's kind of into a biology kind of a thing and how your eye works. But from a human factors, that's good to know. If you were building a clock and somebody wanted to look at it out of the corner of their eye, you don't want it to flicker.
Yeah, I thought it was kind of interesting.
Anybody familiar with the potato chip phenomenon of digital displays? If you are eating a potato chip and you're looking at a clock out of the corner of your eye, you can definitely see it flicker as you're chewing the potato chip. You can try that. I don't understand why it is, but you can try that sometimes. I've tried it with my microwave clock, and it actually it does seem to flicker. Don't know why it is. Anyway, back to this. We've got at least a safety factor of 2, or it almost sounds like 3 built in. So we can be off by a little bit. So let's use an 8-bit counter. Well, I have an ant on me. Okay, let's use an 8-bit counter. Not 89-bit counter. Bit counter. And look at divide scenarios. So if I take the number of ticks and I divide it by 8, that comes out to 8333. That's still way too big for an 8-bit counter. If I do 6667 divided by 64, that's 1041, still way too big. 66667 divided by 256 is 260. That's still a little bit too big. We get 65. Lo and behold, that's where the 65 came from. Where did this 8, 16, 256, and 1024 come from? Well, let me go to this wonderful contraption known as a data sheet. And that's not what I wanted to move. Okay, wait. Okay. Can you see the data sheet now?
Yes.
You can, thank you. All right, this is the register description for the clock scaler. I can do divide by 8, I can do divide by 64, 256, 1024. That is where these numbers came from. Divide by 8, divide by 64, 256, 1024. I will tell you, and it's important to remember, different timers have different scalars. Some have a 32 in here, some do not. So if I were to, I'm not going to go look at it, but some timers will do a divide by 8, divide by 32, divide by 512, and things like that. So it's important to look at the specific timer you're using to know what the divide by factors are. No. Okay. All right, so that's where the 65 comes from. A question we should probably look at is, how exact is that 65? So what's the real frequency? So
I mean, the scalar itself throws it off by some, and then you're doing other things in the ISR.
well,
So
okay, yeah. So as AJ points out, the code adds some stuff, and in addition to the delay. So, but a frequency, it's going to be 1 over t, which is 1 over 65 times the clock divide by 1024 times 62.5, I'll get there, nanoseconds, which comes out to be 240.039 hertz. So in this case, you could do a percent error, but it's absolutely minimal, and will work fine for our purposes. Again, if this were a spacecraft and we were doing a course correction by pulsing a rocket or something, I'd really want to look at that a lot closer, but for purposes that we're doing, that's going to be fine. All right, now what?
Still there, Ben?
Say again?
His camera cut out.
Oh, okay.
I did that intentionally.
Okay. Yeah, when I am sharing my screen, even though I'm not sharing the screen that your pictures appear on, I only see the first few. So I see AJ and I see Ben and I see Cedric. So if somebody else wants to talk, if somebody else wants to get my attention, you can't wave. You've got to actually say something. And I hope when I go to 3 screens, I will be able to see all of you all the time. Let's go back to here, and okay, hopefully now you see a Atmel Studio window, and we're gonna unfortunately redo a little bit of what I did last time, because what I was using as a template, I was actually changing on the fly, so this may or may not exactly match what we had before, but I think it's going to be close. So we had created a show digit function, what it was we wanted to display, where we were going to display it. Up top in the program, we had a segment table with all the different segment patterns. We had a val, which is going to be a 16-bit quantity or a 4-digit quantity. Strobe reg is which digit we are strobing with this display digit routine. So I think I had a variable temp called t, and I said, first off, I'm going to set t count 0 equal to minus, no, okay, that's in the other routine. We're going to say switch where case 0
So for C code, if you
Okay.
have more variables than you do registers, would it store things in the data space or something like that?
Yes. Where the question is, where will this T get stored if it's not a register? And for that matter, where or what and where going to get stored? And the answer is they are going to get pushed onto the stack before the routine is called. So when we have our yeah, okay, I'm a little bit off here. This stuff belongs up in the interrupt service routine.
I don't think there's such a thing as a store, as like a push immediate. So would it put it in a register and then push it?
You mean when it's, okay, when it is, hold that question, AJ. Let me write the code and then we'll talk about how that gets called. So when we get here into this register, into the interrupt service routine. Now, okay, let's go back to display digit. I'm going to say port B is equal to 0. I'm going to turn off all the displays. I'm going to say port D is equal to what? Here, the seg table sub what? And then I'm going to say port.
You're missing a semicolon.
I am, thank you. Port B is equal to 1 shifted left by 3 minus where? And that's kind of that's because bit B0 is connected to the 3rd digit. So where I want where to be the rightmost digit, that's actually connected to B0. I need, oh no, sorry, connected to B3. I need to do the 3 minus the where. And I believe that's it. That's where, let's just go back and test that. I have set up registers here. I'm going to, let's just comment all of this out here for the moment. And let's do a display digit.
Are you missing an opening semicolon in the while loop?
Am I missing?
I mean,
An opening bracket. Very possibly. Let's display let's display 7 on digit 0. And I think you are correct, AJ. I am missing an open. No. Okay. All right. Let me plug my board in now. Let's just try to run this now. And actually, I didn't put a prototype in there, so it's going to complain.
oh, prototypes are still a thing here.
Prototypes are still a thing here. Yep, they absolutely are. Let's see if it.
Don't you need a semicolon at the end of your function prototypes?
Yes, I do. It was in my mind and then I forgot about it. So let's try this again. 43. Oh, I'm just going to get rid of that for a minute. Unused variable 19 and 41. All right. Those are both warnings, but I want to look at it. 19. that's an unused variable. I understand that. 41, that's an unused variable. That's okay. All right, so let's. The border plug. Okay, and if I, can you see me holding up the board now or not?
I
Yes.
can see it.
Okay, so I got a 7 on digit 0, which I think is what I said to do. 7 on digit 0. Let's just put a 6 on digit 3 and run this again.
Oh, will this automatically do the hex conversions?
Yeah, well, let's, I think the answer is yes, but let's put a 12. I mean, I could put a 0xc there too. Let's put a 12 and I should see a C on the most significant digit. So start with our debugging. It is compiling, loading, and lo and behold, a C. Okay.
Oh yeah, right, because it takes it from the.
Takes it from seg table. Yep.
I thought for this lab that we only have to count up to 9.
Yes, it does. But the routine only needs to count up to 9. Your program only needs to count up to 9. But this show digit routine, this display digit, will display anything 0 to F. So, but your program will, when it gets taken apart in this interrupt service routine that we're kind of going to rewrite now, since I don't know why I didn't save it last time. It's going to reset. It's going to only do 0 to 9.
This is going in the public folder, right?
Yes, this is going in the public folder.
Okay.
And the part of the problem is I am not VPN'd in now because it's much, much faster to stream than not go through UMass. And after class, I've got to VPN in and then move it to the folder. So
You could just do what Marcel did and write a script to do it.
yeah, it's okay. He wrote a script to copy something, the VPN and copy something.
Yep.
Okay, if you could, I presume there's a password in there, Marcel. If you could email that to me without the password, obviously, I'd appreciate that. I've thought about that, and I thought that was somewhat difficult to impossible. But if you can, I'd like to see it. Also, with regard to anybody that has a Macintosh that has been having problems, I believe there is a solution. It has, the VMware has been, through a lot of work of Andrew, been made such that you can connect devices remotely, like for example, your 328 board. And it has been tested remotely on a PC. It has been tested on a Mac on campus. And Tim, I don't know if you're on, but Tim was gonna check it on his Mac remotely. And if that does work, then I'll push out the directions to everybody. And if you have a Macintosh, you now can do labs and create stuff. So hopefully Tim, I don't hear Tim, so Tim may not be on, but Tim said he was going to test it this morning through email. All right, so let's do a switch strobe reg and case 0. 0 is the least significant digit. So I'm going to say D is equal to val mod 10 and break. Case 1, D is equal to val divided by 10 mod 10 and break. Divided by 100 mod 10 and break.
And that's to save you from having to do bit shifts.
Well, if you're doing hex, you can do bit shifts. But if you're doing decimal, bit shifting isn't gonna help you any, because it's not a case of this set of bits corresponds to a given digits. That's only true in hex, which is why I made the program you wrote in assembly language much easier, because otherwise you would have had to write a divide routine, which is doable. And if you ever have to do it, I just advise looking it up on the internet and code there and giving credit, because it's hideous. And, all right.
I think you forgot mod 10 for case 3.
Okay, good question. Do I have to put a mod 10 here? And the answer is, if the value could be greater than 999, yeah, I do. So you might want to, it can't hurt to put a mod 10 there. If you're sure it's never going to be greater than 4 digits, then you wouldn't put a mod 10 there. So good question. If for some reason it's not 1, 2, or 3, I return a 15. I don't know exactly what we do with that, but just indicate there. So once I figured out what D is, then I'm going to say display digit. What is D and where is Strobridge? And the last thing I'm going to do is say Strobridge is equal to Strobridge plus 1 ANDed with 3. And the piece that I left out of this initially is G count.
Hang on a second. Isn't int 8 in this context just the same thing as an unsigned character?
Yes. Okay, what's the next part of the question? Well, why am I using uint instead of unsigned char? Because if you were to at some point take this program and port it to a super duper at mega something or other, and perhaps unsigned character defaulted to Unicode characters, which was 2 bytes, it changes everything. It's now a different size. This is always going to be an 8-bit unsigned integer.
Oh, okay. Thank you.
Because this is, actually I've started in 160 encouraging people to kind of use this sort of a nomenclature, because it's universal irregardless of what compiler you're working on. So you can control whether it's 8, 16, 32, 64.
Oh yeah, didn't you mention that in 160, but we never really had to use it?
Well, probably, yeah, when you guys had it, I did mention it, and I didn't really try to get people to use it. And now I'm trying to get people to use it, because it seems to be like, this is a new convention that people are using. All right, I believe, although this is not tested, which we're going to do right now, generation mode, clock scaler, I believe this is now correct. So let's get rid of this comment here. Let's get rid of that display digit. And let's say val plus plus. And I'm going to throw in here, I didn't do this last time, but if val is greater than 9999, val equals 0. So it will roll over from, after 999 is displayed, it will roll over to 0.
Oh, is that also a thing people are doing now? Putting one-line ifs on the same line? I've noticed it recently.
This is kind of my preference, because I like to see as much code as I can on one screen. Depending on what entity you're working for, who's ever paying you, they may have there are lots of times very strict requirements about how you write code. And one of the requirements might be you do the if, and then even if it's one line, it goes in the next line. If that's the convention and the requirement, that's what you do. If you're like me, and I prefer to see as much code on a screen full as I can. And that's why I do that. Oh, you can do whatever you want as far as I'm concerned. Let's just see if this compiles. Yep, okay, so debug start without debugging. And well, it got to 0, but I'm not exactly impressed by any. So what this tells me is the display routine is working, the interrupt service routine is working, because otherwise just one digit would be lit, but the count is not happening for some reason. So let's go back and look at that.
Is it optimizing it out for some reason? Or is the interrupt flag somehow cleared in the ISR? I don't think that's a thing.
Nope. No, because if the interrupt flag was cleared in the ISR, it would just display one digit.
Yeah, I was encountering a similar problem in the assembly thing. I just kind of, I mean, I don't like admitting it, but I kind of brute force fixed it. So
Okay. You can see the display now, right? You can see the program?
yeah.
Okay, I'm going to try, and this, I'm not sure the volatile belongs before or after. Volatile. Not turning blue because I'm not spelling it right. Wait a minute.
Volatile?
Volatile. If this fixes it, I'll tell you why I did volatile. If it doesn't fix it, I'll tell you why I did it anyway. Let's just say. Okay. Now that's counting mighty, mighty fast. Last time I put a delay in there, so I'm going to put another delay and then we're going to run it. But note, it is doing something different now.
The MSB just kind of seems to be cycling really quickly. I don't know if it's going in the right order.
I think I'm watching it. It seems to be 2, 3, 4. Yeah, I think it's going in the right order. But let's.
All right, might just be a thing with the camera's refreshed.
Sure. Oh, that could be true. Yeah, last time I had a delay in here. All right, and it's loading. No, the builder. What the heck? Oh, I didn't put a include. Let's define FCPU one more time. All right. That looks pretty good now. Now, why before did it not work? Without the delay in there, why did it not work? And the answer is, as AJ, I think, said, there was an issue with the compiler optimizing this away. As far as the compiler was concerned, in this while loop, val never got used. And therefore, what's the point of doing all this? Since it never gets used, you don't output it any place. Based on this routine, it got optimized away. Now, because it gets used in case of the interrupt routines, obviously there was a problem. There is a keyword volatile, and that says never assume anything about this variable. Even if you say x equals 4, if x equals 4, never assume that x is 4. Check it every single time. And that's why that fixed it here.
So that's more of a signal to the compiler than it is anything that it does with the data itself.
Correct. That's a signal to the compiler. Don't assume anything about this particular variable.
So don't optimize redundant operations away.
Correct, correct. Now, in terms of passing things to the functions, if you were to look at this assembly code, which I'm not going to do right now, but if you take a look at the list file that puts the assembly there, prior to this statement, you would see a move D into a register and push that register onto the stack. Move strobe reg into a register, push it onto the stack. Actually, I think it would be in reverse order. It starts at the end. Then there would just be a call display digit. Display digit would then use these things by means of, if you recall, there's a load and a store with a Z register plus a displacement, which can be positive or negative. It would copy the stack pointer into the Z register, and then it would use a displacement, minus in this case, or actually plus, to get variables that are on the stack that were pushed. And again, this isn't a course, where do you cover that? I'm trying to think in what computer engineering course you touch on compiler design. Not sure.
I don't think there is a compiler theory course for computer engineering.
No, there isn't a compiler theory, but I would hope you touch on, probably in computer architecture, at least when I taught it, which was more than 20 years ago, we touched on calling conventions like that. So probably there's some kind of a computer architecture course, probably in there, or maybe in the algorithms course you touch on it. I have to check on that. I'm not sure where that is.
I think it's one of the 300 level courses.
Okay, all right. If there was a temporary variable, if there were any variables inside of this display digit routine, they would get allocated space on the stack above the stack pointer. So a negative displacement from Z after the stack pointer was copied in there, that would be a local variable. A positive displacement would be something that was pushed onto the stack. And that's the whole reason that displacement with Z exists, is to be able to access parameters when you call functions. Okay, now, one of the things that is somewhat bothersome is the fact that you set T count 0 equal to -65 each time here. And in the time that it takes to process that interrupt, there are a bunch of clock cycles that go by. And I've either got to account for that in this number, or I've otherwise got to somehow deal with it. If the timing needed to be very precise, there are much better ways than normal to do this. And one of them is clear timer on compare match, which we talked about. Again, I know it was before vacation, but let's go back and look at that.
Oh, other question?
Yep, go ahead, AJ.
Because it's resetting the counter before it does a bunch of other operations, won't it constantly do the interrupt earlier in the code until it goes back to the bottom?
The answer to your question is no, but I think you raise a really good point. The question is, if I reset it here, and while I'm in this interrupt service routine, it times out, is that a problem? The answer is, if that happens, it's an absolute horrific problem, which is one of the reasons you want to make your interrupt service routines as short as possible, or as short as possible execution time-wise. Doesn't make a lot of difference how many lines of code there are, as long as it's short execution-wise. So the question is, how long is it going to take to execute this versus how long before we get the next interrupt? Now, this mod stuff, if you look at divide routines, this might take 100 cycles to do this mod and this divide. So actually 100 for the first time, let's say 200 cycles for one of these. So going through this, I've got to compare, that's a couple of cycles. a divide that's say a couple of hundred cycles in a mod. Display digit is just a few cycles. Let's say it's 25 cycles. And this is another couple of cycles. This is probably safe to say it's less than 300 cycles. So 300 cycles versus 65 times at 1024 cycles. I'm definitely in a safe mode here. But if I was doing a divide by 1 and this was like 5, I'm screwed. This code is not going to work. So that's something you always want to evaluate in an interrupt service routine is how long is it going to take versus when is the next interrupt going to happen. So something to definitely keep in mind there.
Could you kind of sidestep the problem by just putting it at the bottom of the interrupt routine?
That would sidestep the problem, but if the objective is to call it every X number of microseconds or milliseconds or whatever, then you're going to make the delay in calling it a lot longer than it would be otherwise. So yes, it would sidestep the problem, but it potentially creates a new problem.
So now my problem has a problem.
Yeah, yeah. I fixed the thing I needed to fix, but I broke something else. Okay, other questions from anybody? All right.
Related to this?
Well, related to this, but go ahead. If there's another question, go for it.
Where would we find this on the M drive?
Okay, you will find this when class is over. I will VPN into the university, and I'll put this on the M drive. And I meant to do that last time, and I didn't. But let me. So.
If you still don't have a display or the microcontroller, what's your option?
The options are I sent a link to a few people. I'll send a link out to the class. Let me write that down too. Or display.
Like a link to buy it or just like a virtual display?
No, the link to buy it. Amazon, you can buy 5 of them for $6. Or you can buy 1 for $8 as near as I can tell. So obviously, I don't know why anybody would buy the 1. Right now, I am supposed to be put on a list which allows me onto campus. As soon as I know I'm on that list, I will go into campus. I've got requests, I know, I think from 5 different people that they need to be mailed boards. I will mail them the boards, and then you can begin to do stuff. I know some of you are without boards. As soon as I find out I'm on that list, and supposedly access to all of Dion and Senge and Violet and Textiles is only through one door, and your key card needs to be programmed to get you in that door. I don't know how true that is, but that's what the emails have said. So as soon as I find out I'm on that list that my key card works, I will go into the university, I will get the boards, and I will mail them out to the people that have requested them. If I haven't emailed you and told you I have a board, then please send me an email and I will add your list, your name to the addresses that I'm going to send to. Other questions?
Really quick, I sent you the code that I use for downloading stuff from the M drive, but I just want to make a quick note. Like, you have to sign into the VPN before. Like, you have to go, like, set up the VPN before you could do anything, or else it'll block it.
Correct. Yeah, you cannot get to the M drive unless you are VPN'd in.
Yeah.
It is much faster to you if you're going to, well, okay, I take that back. Yeah, okay, you need to be VPN'd in to use.
Because it uses Linux.
Okay.
If you're going to use the Linux remote desktop, you need to VPN it.
To use the VMware Horizon client, you do not need to be VPN'd in, and you can get to the M drive. Yeah, that is correct. If you want to access the M drive, and this is not recommended by CITS or by any administrators, but it is possible to access the M drive by doing net use, and you've got to look up the command. Some people have told me that, but that's not recommended by CITS, and potentially it can lock you out, lock your password. So obviously that's a problem. To do that, you do need to be VPN'd in. Okay, let's look at the data sheet, which is EA. And I want to look at setting up a mode other than normal. Specifically, I want to clear timer on compare match. Okay, this is 0, right? Yeah. Okay. Well, again, this was, again, before vacation. That was the class I was late to, and Ben showed you how to use that without actually writing any code. Now we're going to write a little bit of code to do it. This says, this mode says the counter is going to be cleared when T count reaches whatever is in output compare register 0A. So the counter is going to count up just like it normally does, subject to the divide by settings. When it gets to the value in OCR 0A, it will clear itself. So if I put 65, not negative 65, but 65 into OCR 0A, I never have to worry about setting that again. Every time it gets to that value, it is going to reset. So I can come over to my code and I can take one line out of this interrupt service routine. And up here, I'm going to, instead of setting this to negative 65, I'm going to say output compare register let me look at my cheat sheet, OCR 0A. Okay, just it didn't show up and I didn't understand why. I'm going to set that equal to 65. Now, not 66, let's set it to 65. Okay. Now, for those of you that intimately remember that original lecture, there's still going to be a problem because I had set interrupts to occur on the overflow flag. Let's go back and look at this TI mask 0 register. And that's in the data sheet, which is here. Does it list each of the registers? Okay. All right. This is my interrupt flag register. The overflow flag was set in this register by the hardware. And based on, where's my, okay, there's my interrupt mask register. Based on me setting this bit, okay, remember TOI E0? Let's go back and look at the code for a second. Why did that work at all then?
Yeah, that's me debugging.
I guess what I did is I copy and pasted this code. All right, I am sure last time, and you can go back and verify this if you want. Last time in the code I had TOI E0.
Yes.
Okay. And that should have worked. I do not know why it worked when I just did what we were doing. Actually, I bet, okay. I don't know if this is a confusing moment or an educational moment. Well, no, that was in normal mode. It probably, actually, okay, I do know why it worked. I don't know, I gotta think about it. What I'm thinking is it rolled over anyway. I don't know. Tell you what, let's leave it like this. Using output compare, I expected I was going to change this particular flag to be this output compare interrupt enable on A as opposed to this particular flag. In the interest of just checking to see what happens, I'm going to run it like this. I'm not sure I expect anything to happen, but let's see what happens. Right, downloading and running. Okay, and absolutely nothing happens, which is kind of what I expect. I am not sure what was going on, but if I also expect if I change this to OCIE0A, OCIE0A, that now that is going to work. Every time T count gets to be 65, it will clear on compare match. Oh, I gotta change one other thing actually, but it will clear on compare match and fire this interrupt. The other thing I need to change here is wave generation mode. Let's go back to A, where we have a table for wave generation mode. And we're no longer going to be in normal mode, we're going to be in CTC mode, clear timer and output compare match. And we see it's 0, 1, 0. Okay. 0, 1, 0. Yep. So 0, 1, 0, I go back to my code. And I'm going to make this 1, 0. The most significant 0 is right there. So it's 0, 1, 0. And let me cross my fingers where you can't see it. And run this. Okay, and we're good. All right, so we've used a timer in 2 different modes. One is normal and one is output compare. And how are we doing on time? Oh, wait, I'm way over, I'm sorry. Okay. Again, I would hope by today I'm putting that list so I can get it either today or tomorrow. And the people boards out that need boards. If you need a display, I think there are still some displays in the bag at UMass. Send me your email, tell me you need a display. I know some people have already ordered them. I'm not sure how many displays I've got, so if you've ordered them, please don't ask me for one. But if you haven't and you need one, ask me. And
Are you talking about the 7-segment displays?
7-segment displays, yes.
Okay, good. Yeah, thank you.
All right, on Monday, what we are going to begin is looking at serial input output. That is through your program, you're going to be talking to the PC through a terminal window, and you're going to be sending characters from the 328 board to the PC and from the PC to the 328 board. And I think some of the experiments, instead of using an LCD, since in order to get those to you, there's some soldering, I need to ship out 40 of them. I think I can teach the same concepts using the UART display, and we can do things that way. So some of
That sounds like it has the potential to break a lot of things.
what has potential to break a lot of things?
Sending stuff from the chip to the PC.
No, because you do it over the USB port. So it's not like you're plugging anything else into your PC.
As long as I don't overwrite my operating system, I should be good.
I do not believe it's, without running some weird code on your PC, I don't believe it's possible to overwrite your operating system.
I hope not.
Yeah, I'm thinking in terms of a USB that you plug in that potentially infects something. Now, you always on your PC, it would say your USB device wants to run some code. Do you want to allow it? It would be wise to say no if your 328PB board does something like that. But in general, you're just sending characters back and forth and not code.
All right.
Any other questions? Okay, I believe I need to copy this code to drive M, link to class. All right, God, I wrote a note. Link to class for display. What does that mean? I just wrote that down and I don't remember what it means. Oh, okay. So I send out a link to everybody if you need to order for 7-segment displays to order.
What's the plan about the LCDs too for Feature Labs?
My plan is probably to not use LCDs because that would mean mailing out 40 of them.
Yeah.
I need to order 40 of them, solder headers onto them because they don't come with headers.
Okay.
I know some of you can solder and some of you are not that good at soldering. So I think I can sort of teach the same concepts without the LCD display. I may ask you to order an LCD that's either SPI or I2C. Again, I want to look at the labs. I want to look at prices. I don't, if it's something that's going to cost you $5 or $6, I think you've got to bite the bullet and probably order something. If it's in the $20 range, I don't think that's too reasonable. So I got to look at a price for something like that.
The other day, I tried to order something off of Amazon, and it said it wouldn't arrive till like April.
Yeah, I know. I'm getting the same thing. And that's, again, that's another problem with even me ordering the stuff. I don't know. Has anybody had any experience? I know they're saying they're not going to order stuff till April, but does anybody know whether it's actually coming a lot sooner than that, and that's just a safety in case thing?
So the way it works is that like Amazon products that are actually from the warehouse arrives between next week and April 15th, but third-party sellers will arrive at the end of the month because they have to go through basically like a step of sanitizing their products and stuff. So that's why it's coming in at the end of April, because it's a third-party seller.
I thought it was.
So they basically have to package stuff and then not touch it for 2 or 3 weeks?
Yeah, so like they basically have to like make sure like these products are actually like sanitized and like make sure that they're all set, like all good, because they are third party. They're not exactly a product of Amazon. It's someone that's selling to Amazon, and Amazon is selling that to the customer.
I heard that Amazon was sort of prioritizing medical stuff first, and everything else was secondary.
Yeah, I think
non-essential
that's
things are more likely to be delayed.
Yeah, so you can almost order off of AliExpress and get it faster, I bet. I don't know.
You could order it from Wish if you don't mind a small little viral package being attached to it.
Yeah. Yeah. Okay. I guess that between the delay in shipping and other stuff, we're probably going to be doing a lot of stuff using the UART and the computer, and you will sort of type things to light up LEDs, type commands to your board, things like that. And again, that's not ideal, but I think that may be the only choice. Because I don't think, I don't think the university has got 40 displays around that I could send out even. I think we ordered the lab partners and we don't, did you know, Kevin?
I think we had maybe 12 at most, and that's why we had to order some.
And before all this ruckus happened, we had just figured out how to order from Amazon. The university had figured out how to order from Amazon because there was a problem if, this is the state, if Amazon charged sales tax even to the state of Massachusetts. State law apparently says the state can no way, no how pay sales tax. So it's perfectly okay to order it from somebody else and pay $10 per LCD display, but it wasn't okay to order it from Amazon and pay $3 plus sales tax for the display. And this was fought at very high levels, and the university lost the battle. But Amazon eventually somehow said, okay, if you do this and this and this, and this was, Dr. Violet did a lot of this negotiating with Amazon, then you can buy stuff and not pay sales tax. I believe that had been completely put in place right before the shutdown, and then LCD displays were going to be ordered, but they didn't get ordered. So that's kind of where that happened. Okay, obviously, if anybody wants to drop out, that's okay.
Yeah. Oh, Kevin.
Any other questions?
While you're on the call, can I show you the thing working? Because I meant to send the video.
Yeah.
I considered the stuff in the ISR critical code, so that's why the refresh stops when you push the button.
Okay.
So how is this working for lab?
Okay, for lab, it's kind of a, Kevin will be doing a virtual lab.
Nice. Okay.
And
All right, thanks.
And checking you off. Lab reports, again, there's some leniency because I know some of you still don't have boards and some of you don't have displays. So there's some leniency with due dates. Once everybody has a board and a display, it's expected they'll about a week, a little bit more. I understand. I know I heard from somebody, I'm not sure which class they're in, but they're, one of their parents works in the healthcare field and is symptoms of the coronavirus. So I understand people are having problems and this whole situation sucks. So I'll try to be as nice as can be.
So are we still working in groups over Zoom, or?
If you and your partner want to work virtually, or if you are with, this is by no means a requirement. I've had a couple of people ask me and say, my partner and I live just down the street from each other. Can we get together? And I said, if you are both comfortable with that, that's okay. If you are comfortable working virtually with your, if both partners are comfortable working virtually, everybody at the university can do meetings of 3 or less with no time limit, meetings of 3 or more with a time limit of 40 minutes. Kevin, I have submitted another trouble ticket on your 40-minute limit. I'll see what I can do to get you a pro license.
I don't know. So Tim told me to sign out and sign back in, which is what I did this morning, and we might be okay.
Oh, okay,
okay. Now it says licensed.
It says pro license now, or?
It just says licensed, and it didn't give me that warning about the 40-minute time.
Okay, so if it's fixed, then I won't bother. I'll retract that ticket.
Okay.
Well, they may just tell me you're a jerk file for it's already been done.
Yeah.
And also, if we're working on the assembly code for cycling through the hex digits prior to vacation, is that the one that we're going to show next lab, or are we going to work on the C version of that this next lab?
The thought is the lab on today and Monday, you should be doing the C version, but I would encourage you to get the assembly version working with hex.
Yeah.
Before you start working on the C version. If you've got the assembly language version working, it should be really easy to do the C version.
Okay.
So I would encourage you to do the assembly language version first.
And really quick as well, is there any way to, how did you store values in a hex into values? I don't know how to explain it. Like,
Okay.
how would I be able to store a hex value into a variable and then get that hex value back?
I think we're supposed to use define byte.
Oh, okay, are we talking about the assembly or are we talking about the C?
For C, because I know in assembly you could just pass it the hex value, because I was using the hex value to store the entirety of the number.
Okay, what I did in C, am I still sharing my screen? Can you see it?
Yeah.
Okay, I just created a 16-bit value, 16-bit variable. I called it val. You could call it anything.
Yeah.
And within the C code, in here, rather than just incrementing it like I did, you're going to be looking at the buttons, and based on which button it is, you're either going to be doing a val plus plus or a val minus minus, or a val equals 0 in the case of the center button.
Mm-hmm.
All you have to do is, assuming you do an interrupt routine like this, and again, this is designed to be very helpful to you. If you do an interrupt routine like this and you change the value of val in your main program, magically it updates on the display. You don't have to do anything else. Does that, am I answering the wrong question?
I'm saying, because the C version, are we using hex or are we using decimal for the C
No, the
version?
C version you're using decimal.
Oh, okay, all right, then it should.
And you take the 16-bit value apart with this code right here.
Yeah.
If you wanted to do a hex version in C, one way is to change this to mod 16s and divide by 16s. The other way is just to do a shift left by 4 bits and some ANDing with F and a shift left by 4 bits.
Yeah.
So, but in the case of C, it's...
And are you making this available like right after this, or do we
this
have
code,
to...
yep, after I end the meeting, I will get on with VMware and I will copy this code into the M drive and name 7-segment refresh.
Okay, and this is going to be in the notes, or is this going to be in book code?
It will be, where do I usually put example code? Do I usually put it in notes?
I can't remember right now.
Okay. Yeah, I can't either.
You usually put it in the public folder.
Oh, yeah, that's right. I usually put it in public. I'll put it in public.
Okay.
So this code will be in public.
All right. Thank you.
Is there a handout for this lab, or is it just the same as the code we did in assembly?
There is a handout which I have not distributed, but I will put a handout, and I'm writing this down now, in the labs and homework or labs and project folder.
Okay. Thank you.
Okay. Anything else?
Just as a quick refresher, how do you switch Atmel Studio to C again?
Okay, to create a new project, you do File, New, and Project.
Yeah.
And then GCC executable project as opposed to
Okay.
an assembler and assembly project. So
it's just based off the file type, correct?
right, it's when you create a new project, you tell it whether it's a C project or a assembly project.
Okay. All right. And does Kevin need to see our code as well for the labs?
Your code should be in your lab report.
Yeah.
I don't think Kevin needs to see your code to verify it. With that, you concur, Kevin? He may have left. He probably have started another group with lab.
Okay.
Yeah, he's gone.
He's gone. Okay. So I think your code obviously needs to be in your lab report, but it doesn't have to be in your. You don't have to show it to him to get him to check it off.
And how do we get into the lab when it's time? Like, do we need to?
Kevin should have sent you a link of some kind.
Oh, okay, so he's gonna email us. Okay.
Yep.
All right. Thank you.
Okie doke.
All right.
I'm going to stop sharing my screen, and I will see you on Monday.
All right.
See you Monday. Have a good weekend, everyone.
You too.
Toodaloo.